So let's start. Okay, so I'm going to use Google Colab. You can use anything else if you're familiar with Jupyter Notebook, if you have offline Python IDEs in your local machines, you can use anything. But I'm using Google Colab for my convenience. As I told you, right? You have a variety of food. You have to choose what you prefer. So I have the codes written already. I'll show this shell. Okay. So if you don't see, I just zoom in a little bit. So we import the package from Deepface, import Deepface. We are going to use this Deepface here. So let me. So you can type this command. It's done, I think. Okay, so give the first command as install Deepface. Yes, done. Okay, the second step is just import it. Now I'm going to use the Google Drive. Okay, I have uploaded my data set here. I'll show you my data set, how it looks. So this is my, okay, it will mount the entire Google Drive. Then later from there we can actually map it to our path. So let me run this. So it may ask you to give the permission, just say yes. It's mounted. Now, I'm just importing other libraries for plotting the images, just to display the images. I'm using matplotlib.pyplot. I'm using that here to just display the images. Now, I'm going to do the first one, which is actually matching, verify. Deepface verification. Verification is to check if two images have the same face or not. Okay. So I'm taking the first image as image 1. The second one is image 2. So if you want to see what is image 1 and image 2, if you go to your data set, you can see image 1 is, who's there, right? Angelina Jolie, right? Okay, so image 1 and image 2 is what I'm going to compare. Any human vision can say that these two faces are correct. The same persons, right? Our human vision need not know whether it is Angelina Jolie. We know that two persons are same. Right? The Deepface also does the same thing. Deepface doesn't know whether it is Angelina or somebody else. He'll just match whether this face matches or not. Right? So we are using the first one is detect image. The whole picture. So the picture is too large. Right? It's a big one. I just want to crop only the facial portion. So for that you have to apply detect face. So that is a method here, detect face. So let me run all these things. Done. I'm taking image 1. I'm taking image 2. Now I'm just detecting that and storing it in another variable called IM1. Similarly, the second one in IM2. So if I display that cropped image portion only, so I get the face, right? So rest of them are not interested. So similarly, I have the second image, right? Now, I told you that Deepface supports many models. We are going to use FaceNet. You can use BGG Face or Deepface, any model. You can experiment it by yourself. So change that. Now I have given FaceNet. You can change it later. I'm going to apply verify. So this verify is going to verify whether these two images has the same person's face or not. Okay. So let me take this FaceNet model, and then I'm passing both the images and their paths, and then now works. Yes, it's actually comparing both of them. Okay, so it has also given other parameters like how much time it has taken to complete this, right? Now let's see what is there in the result. You can see the outcome is given these parameters. It says it's verified, successfully verified. The result is true. So both the images are matching. It's of the same person, right? So the distance is also very less. The smallest distance gives the highest matching. Excuse me. So other parameters like you can see the model which has been used, and the detector backend OpenCV detector has been applied. Now I go to another method called find, which means I randomly feed one face and I check if that face is available in my entire data set. Okay, it may be there, it may not be there. I'm just feeding that, right? So I'm loading another image called find. So from the data set, you can see what is find. So his name is George Clooney. His face has been fed. And if you look down in your data set, somewhere around 38, his face is there. Right, you can see here. I have 4 of his faces already there. Visually, I can say it is there, right? I'm feeding a different look altogether. You can see here. I apply that find method to check if it is existing there, right? It all depends on what is the resource you got in your cloud. Suppose if you have a full subscription, you can actually go for a GPU based, and this will work like a charm. It will come in few milliseconds. The results will come. Okay. It's actually comparing the entire data set. That's why it takes a lot of time. It's now more than a minute. You can also see the data rate. So this is what will happen if you keep your data set in the cloud and if your device is every time comparing. You got it. For example, we have a huge data set which takes all the students' attendance. It's better to apply the Edge API, Edge AI, than sending the data set to the cloud, right? Right, it's done now. Let's see what is there in that image, how much it has found. Yeah, it has given me, I think, 5 results. You can see 38, 41, 40, 39, and also 59. So let's see the numbers here. So 38 is there. Yes, it's a match. 39 match. 40 is match. 41 is also match. So what is there in 59? Oops. That's a misclassification. Mismatch. Okay. It's not the correct match. Okay. So it also gives you the parameters of match. Right. So you try to feed the Rajnikant's face and then see whether it matches with anyone. Right. Instead of that find.jpg, load your favorite actor's face and then check if it matches with anyone. It could match, right? It may be a mismatch, but just see which looks closer. And then the final one is the analyze. Okay, analyzing the face. How the face looks like in terms of the age, gender, and ethnicity, emotion, and other things, right? So I have already fed that image one path, which is actually the first image of Angelina, right? So let's see how this works here. So that is using the Deepface.analyze model method. So it actually analyzes. So you can see that the weight H5 has been downloaded and it's been used here. That's a pre-trained weight. No, we are not interested in the bounding box. If your outcome is if you want to visualize the outcomes in the bounding box, you have to go with like YOLO models. This is giving you only the parameters. I told you, right? Computer vision algorithms need not give you the images as output. It gives you what you want as an understanding from the image. It gives you, I'll show you the outcome here. Once it is done, it just gives you some text parameters. That's it. It depends on which distance has been already applied to the model. There are other models, right? I have shown you OpenCV. That OpenCV is to detect a face model. That is a very fundamental method to detect the face. We also can change it to other models which are available. Okay. So I'm just leaving many parameters by default as it is. Face detection. I just want to see if there's a face in the picture. That's the face detection, right? There could be one person in a close portrait photograph. There may be hundreds of people in a photograph taken in a gallery of sports. Right? The face may be as tiny as a pixel, but it has to still detect. All the models may not work in all the cases. You have to change your method depending on your requirement. Now, for example, your cameras, mobile cameras, do have the face detection methods embedded in your camera apps. The moment you show multiple faces, it will just show the bounding boxes, right? That's a face detect. It will not know who it is. It will show there is a human face. It will show the boundary of it. Okay, so now it's analyzing here. You can see. Now let's see what is the result here. Only for this image. What do you interpret from here? Angry 8.5. Disgust 0.0. Look at the numbers closely and come to happy emotion. What is the number there? 100. That is a score. Whichever has the highest score, that is the emotion that we get. So it always have a parameter called dominant emotion, which is happy. Age, that is it. And it also has a gender classified as woman. And race, you can see again, there's a score here. There's a score for every race that has been already fed in the Analyse stage, right? So it has well defined. So it compares with each of those races, and then the dominant among all of them is Latino Hispanic. So try to feed again Rajnikant's face and see if it's falling under Indian, okay, or Shahrukh or somebody else. Just try to feed it and check. Right, so you have to do this. Try to do this. Okay, so the methods are very simple. You can try with different parameters. Change the parameters in the method. In fact, you can feed these methods with your own arguments. Pass it and then find out. As I told you here, the simplest thing that you can change is the model name. Change the model name and try the results. Okay. Thank you for the opportunity.